In this video, we are going to review naming multivalent ionic compounds. So many larger elements have more than one valence, or what we call multivalent, because the electron distribution in these elements is much more complex. Unfortunately, you are responsible for memorizing the valences of the elements that are commonly used in this course. So the elements that you should memorize are given in the following table here. You need to know that mercury or copper can either have a +1 or +2 valence, that iron, cobalt, or nickel can either have +2 or +3, tin, lead, and manganese can either have +2 or +4, and finally, nitrogen, phosphorus, arsenic, antimony, and bismuth are all either +3 or +5. There are two main ways of naming multivalent ionic compounds. We are going to, as I said before, focus on IUPAC method of naming, but I am also going to show you the IUPAC method because this is still quite commonly used within laboratories. Starting out with the IUPAC method of naming multivalent ionic compounds, basically it's almost like we did in the last video, where we are going to name the metal first, we're going to name the non-metal, we're going to change the ending to IDE, except now we need to use a Roman numeral after we write the name of the metal in order to indicate which of the two possible valences that metal has. So Roman numerals for 1 is an I, 2 is 2 I's, 3 is 3 I's, 4 is an IV, 5 is V, 6 is VI, 7 is VII. You should memorize these as well. Let's look at two examples then. The first is PbS. If we were determining the valences, the sulfur is -2, meaning that our lead has to be +2. So its IUPAC name would be lead bracket 2 bracket sulfide. Now I tend to spell sulfur and sulfide with the PH, but it's okay if you spell it with an F as well. For the second example, we know oxygen is always -2, so in order for this formula to work, iron has to have the +3 valence. That means that this would be iron bracket 3 bracket oxide. Now the other method of naming, the IUPAC method, I'm going to show you how to do this, but only use this method if I tell you to. Otherwise, always use the IUPAC method that we just did. In this method, instead of using Roman numerals, basically we're changing the ending of our metal name using one of two different endings in order to distinguish the valences of the metals. We're going to use the ending "ic" to indicate the higher of the two valence numbers, and we'd use "os" to represent the smaller of the two possible valence numbers. Now also to use this system of naming, you need to know the Latin names of some of the elements. So for example, iron is known as either ferric or ferrous. So ferrous is for the +2 valence, and ferric is for the +3 valence. Let's try 3 examples then. If we're looking at Cu2O, we know oxygen's -2, meaning that copper has to be +1. Now copper could be +1 or +2. Since it is the lower of the two numbers, it is called, whoops, let's just fix that. It is called cuprous. So we're using the OS ending because it's the lower of the two. And oxide. Our next example, nitrogen, -3. meaning that lead is +2. Now lead can either be +2 or +4. Since it is the lower of the two, we're going to use the Latin name, which is plumbus. Okay, again the OS ending because it's the lower one, and then nitride. Finally, the last example, sulfur -2, means that tin has to be +4. Again, we've got to use the Latin name, which is stanic. Okay, ic because it's the higher of the two, and then this is a sulfide. Only, as I said before, use this method if I tell you to, otherwise stick with the IUPAC method of naming. When you are determining the chemical formula, when you're given the name, you're going to follow these basic steps. You're going to write the chemical symbol for each element. You're going to determine the valence value for the non-metal from the periodic table. You're going to use the Roman numeral as the valence value for the metal, and then crisscross the valence values. So just two examples here. Let's do lead to bromide. So we know lead is Pb. We know bromine is Br. We know the valence of bromine is -1. And this Roman numeral 2 here is telling us that our valence of lead is 2. So we're going to crisscross our numbers down. This will give us a formula of PbBr2. Our second example, nickel 3 phosphide. Let's write out our two elements. From the periodic table, we know phosphorus is -3. And from our name, we know nickel is +3. If we crisscross our 3's down, we get Ni3P3, which reduces to NiP.